Thank you, Radek. Good morning, guys.
Hello.
Yay. All right. I don't know how many people we'll get today. We've got a bunch of people in India for planning meetings and then other people that are off at OpenStack in Berlin. But it looks like, well, maybe we'll have a couple at least. And next week we won't have a meeting because it's the Thanksgiving holiday in the United States. So for those of you, well, I guess for Radek probably, I think Casey and Jesse, are you in the US too?
I am,
Yeah,
yes.
I'm in Portland.
Yeah. So yeah, we'll skip the meeting next week. All right. I suppose it's just 10 o'clock right now. Give people one more minute if they show up. Welcome test, whoever you are. All right, let's get this going. The only new PR that I saw this week was yours, Radek. Drop the append buffer from buffer list.
Yeah, but there is also another one, but marked as work in progress. It's uh, it's mostly for optimizing some unnecessary atomical operations related to the to managing uh, buffer rows just after they are produced. We are doing atomical increment of the nref counter in buffer row, even having the guarantees we are the very one owner of that we are actually the owner of the freshly produced buffer. So even if you don't have any sharing, even if you have the append buffer killed, even after that, acquiring a new buffer row into buffer pointer would require you to do atomical increment. It's perfectly unnecessary, and the change set tries to fight with that. I believe it can be quite important for the Crimson, where by design we want to avoid any sharing. But our buffer list do extensive reference counting, atomical reference counting, even when we are not sharing anything. That's the problem the PR tries to fight with.
This is a big PR.
Well, it's built on top of the hyper combined buffers.
Sure.
I believe they are almost ready to go, and well, it's just a part of the much bigger change set. The ultimate goal is to have buffer. It's to have buffer. It's to have only constant guaranteed iteration over buffer list. Here it's a big branch At the moment, it's work in progress. However, some things are already operational, and I'm dissecting them to send as separate PRs. Ensuring that buffer list can be accessed with some non-modification guarantees would allow us to deduplicate zeros, for instance.
So I have a very terrible question for you. When all of this is said and done, do you think the code will be simpler or more complicated?
I hope it will be simpler. We
Okay.
already killed backward iteration.
Yep.
Now we are going to kill non-constants iterator over buffer list. But still, okay, on the other side, there is hyper-combined buffers. It adds actually complexity.
That was what I was wondering about, is how much that added. But hey, at least you're getting rid of some other things. So maybe on the whole.
Well, I hope
worry,
so, but yep.
I worry, Radek, that if you got hit by a bus, then none of the rest of us would understand it. So maybe we should send a bodyguard to make sure that you're safe.
Well, that's the reason why I'm dissecting patches and sending as separated PRs. I don't want to make the same mistake like with OpTracker, where I pushed a huge branch with dozens of commits that were heavy and hard to understand.
Yeah.
I'm trying to have a series of much smaller PRs.
Okay, cool. Yeah, I'm just looking at your the commits here, and there's a lot.
Yep. There will be several another PRs just by dissecting some things from.
Sure. All right. Well, good job. Keep it up. Hopefully we can get through this and someone will be able to review it all.
So a quick question about the append buffer thing. I think that's kind of an optimization for a lot of small appends to not hit the allocator over and over again. So
Exactly.
is this a trade-off of more allocations but less atomics, or?
No. There will be no more allocations. It could be without the underscore carriage member we introduced instead of append buffer. But well, the carriage fulfills the same role. I mean, it helps you. It gives you ability to reuse the same buffer, the same buffer row
I see.
when you
Yeah.
are facing mixed appends. I mean, C-string taking append mixed with buffer list or buffer pointer taking appends. That's the worst case for buffer
Okay.
list. This leads to
there's
huge fragmentation and a lot of reference counting. It's painful.
still an append buffer, it's just not reference counted like the pointer.
Yes, exactly. It's just alt dump the pointer, nothing more.
Well, Reddick, I'm super excited to see this work on Bufferlist. It's really, really great.
Well, we'll see. And buffer is used everywhere, so it's pretty easy to blow the whole project poking with that. On the other hand, it allows to discover some issues like the crosstalk we have in current bufferlist implementation. And moreover, it's not only a theoretical issue. I was hit by it while working on killing non-constants non-const char variant of CSTR in buffer list. We are using we are explicitly using the crosstalk between buffer list in our EC implementation. Let me provide you a direct link. It's bad thing we need to rework that. Even if we don't want to match any single commit of the rework, we really need to fix the issue because it seems it works by an accident. Yeah, data reintroduce.
Yeah, and I mean the existing implementation, I would point out, isn't exactly easy to understand. So, I don't think you have a lot to worry about so far.
Radek, while you're working on that, maybe I'll keep going here so we can.
Oh, sure.
Let's see, what else do we have? Jason merged this token bucket fill cycle thing. I don't remember what that was. I think I looked at it once. But yeah, whatever. He can figure that out. Don't worry about that. We've got 2 PRs here that got closed that were old and not being updated. So one was this RDMA thing, which, yeah, I don't know. I think it just kind of went by the wayside at some point. People lost interest in it. And then this other one from Joe Mario, he was doing some tests with Perf, the kind of a custom thing that they had done, looking at like cache lines, and found some places. I think it was in our logging code where we were doing like crappy stuff. But no one really ever reviewed it, and I think the whole idea was that we know our logging's crappy and horrible, and we were hoping to fix it in other ways. So I don't think it got a whole lot of attention, but it's been sitting there for like 2 years, so that got closed too. Bunch of stuff that was updated. Another one of your ones, Radek, here, introduced shortcut for reads over replicated pools. Sounds like that's more kind of like a C-star optimization, though, that
Yes,
yeah.
It's driven directly by C-star. Kifu is working to translate the shortcut into C-star constructs to a series of promises.
Cool. Okay. Sounds good. And your hypercombined buffer list is here too, but we just talked about that a little bit already. This librd shared persistent read-only RBD cache. They had some benchmarks there, and it turns out that their volume that they have fits entirely on the cache device. So, I mean, it's good to see that it's faster, certainly. But their current tests did not actually showcase what the behavior of eviction and promotion would be, and that's really kind of where the meat of this is, right? That's what when we introduced the cache tiering feature in Firefly, it was fantastic so long as everything fit on the cache pool. But as soon as you started doing eviction, everything just kind of fell apart. So that's what we need to see, is that this actually does well when you have lots of data that exceeds the cache device space. So that's what I'd like to see from them. See. Oh, another one of yours, Radek. Minimize PG get OSD map. Driven ref counting. Anything going on with that?
I got the network lag. Heard only something about ref counting.
Let's talk about the next 2 here that are yours. 24844 and 23713. One is minimize PG get OSD map driven ref counting, and the other is perf counters with threaded storage.
Yeah.
Those were updated.
So I guess the first one is almost ready to merge. Idea.
You cut out, Radic. I think we lost him. All right, let's move on. Okay, this last one is this EC Stripe cache. That one the review was requested a while back, and Sage finally asked that if Josh or Neha could take a look at it. So we'll see. I'm assuming that one will get updated at some point here in the future. And then there's a bunch of stuff that hasn't gotten any movement this week. The only one I'll mention that I know what's going on with is my PR to improve the behavior of the auto tuner for Blue Store caches. Right now, it's kind of brain dead. It's not real brain dead, but it's sort of brain dead. It will often revert back to the static ratios that have been assigned. Not always, and it does still do some smart things about RocksDB indexes and filters, making sure they stay in cache. But otherwise, it will just kind of tend to eventually migrate back to the default ratios. The good thing about what it does right now is that it tends not to overexert tcmalloc very much, which is good. It's generally faster than not tweaking the ratios at all. The version that I've got here that currently appears to be segfaulting, unfortunately, during QA tests, it's smarter, definitely. It much more accurately kind of reflects what's going on at the moment in the cluster. If you're doing a lot of RGW work, it tends to give the OMAP more cache. If you're doing RBD large reads, you'll get more buffer cache for data. So it does a really good job of that, but the problem is that doing that actually ends up making tcmalloc work a lot harder to fight fragmentation and other things. So it's kind of it's good, but at the same time, I think there's some risk with it. Temporarily you might see tcmalloc like showing much higher fragmentation and the caches shrink because there's not as much space as there was before, and that isn't necessarily always a good thing. So beyond just the segmentation fault, it's kind of a question of, well, it's sort of good and it's not always great. But it's also much easier and much better to get good statistics out of it, and it looks like it's doing really good things. So I think if we can fight where we're introducing fragmentation, this ultimately will be better. But right now we do a lot of nasty memory stuff and stuff. So anyway, that's the only one I'm going to talk about here on the no movement. I don't know about these other things.
Hey, Mark.
We'll see. Yes.
Hey, so this is Alex here. Just relative to your auto tuning, there's a few issues. I sent out an email and everything else. Do you mind if I mention it here?
Absolutely. Go ahead. Let's talk about it.
All right. So right now, me working with Ben, we suspected that we had we did a comparison between default file store configuration with Blue Store default configuration, and seen that Blue Store was underperforming file store. And the first thing we wanted to see is memory utilization. And with the default settings, we were using like 10% of the available memory. So we played around with some settings and trying to get it to at least 50% of the available memory. And we were playing with the OSD memory target parameter. We had I don't know, a false positive from Ceph Ansible. Hey Ben, we had a false positive with Ceph Ansible because in the generated Ceph.com, it was showing two values for OSD memory target, one for 4 gigs, another one for our setting, which is 16 gigs. And then when we did a show config on our OSDs, it was showing 4 gig as well. If we did a PS on Ceph, it was showing that RSS was about 14 or 15 gigs. And then we wanted to see what a dump memory pools would show us as well. And we did a dump memory pools, and it was only showing us 4 gigs that it had total that it was using.
Mhm.
So we're putting the cluster under load with CBT, and I'm collecting the results. And surprisingly, we see that all the OSDs are actually using my setting of 16 gigs. And so there's some inconsistencies as to what the system is presenting the user of what we're doing
Yep.
and what it's using, and then what the OSDs are actually using. And
Yep.
right now, as we're seeing it, it's using the user specified one. We're going to continue to collect the results and analyze them against file store and our BlueStore defaults to see the performance differences. But the major, I think, obstacle is just getting a clarity between what the operator actually understands, what is being used, and that those settings are actually being applied appropriately.
So that's an excellent observation. Unfortunately, this PR that I was just talking about is the thing that also introduces a bunch of performance counters for what memory is being assigned by the autotuner. So, and that didn't make it into a segfaulting. So unfortunately, Luminous and Master do not have that, which would be really useful. I'm guessing that what you're seeing is that the mempool does not account for the RocksDB cache usage. That's not in the mempool.
Oh, okay.
So if the autotuner is assigning a bunch of memory to RocksDB cache, if it thinks that's what it should be doing right now, then you won't see it in the mempool data.
Okay.
There's debugging in the OSD that you can enable, and you should be able to see it there. I'll get that to you. And that would tell you. But yeah, the mempools won't tell you, which is what is unfortunate right now.
Okay.
Take a look at this PR though. In there, I've got the example of the performance counter data that will get dumped when you in this kind of new version of it. Does that make sense? Kind of what's being shown there? It's this priority cache KV, priority cache meta, priority cache data, and it's showing you how many bytes at each priority level the autotuner is trying to assign, and then kind of like the reserved bytes and the total committed bytes for each one. Would that be what you'd be looking for, or does that make sense?
Yeah, it definitely does make sense from what I'm seeing it. Yeah.
A couple questions about it. So
yes.
What is, first of all, does RocksDB fall under one of those categories, meta, or what is it?
Yes. Meta would be the KV is what you'd be getting for RocksDB. So it's called It's called KV because it could be anything, right? It's whatever the kind of whatever's being registered as the key value store as far as the autotuner is concerned. Maybe it wouldn't be a bad idea to actually make that more specific, like RocksDB, right? Rather than just KV.
Or at least, somehow people would understand what it was for. The other thing is there's a difference between reserve and committed, and it's not clear to me. So what is the difference between the two?
So let's see here. Now I have to remember. This was like 2 months ago that I was working on this, and if I don't remember, then no one else is gonna know. So
You're too young for this, Mark. You're too young for this. Come on.
but hey, this is really good though, right? Because you just brought up a point that I don't even remember what I made it do. So if I didn't remember, then no one else is going to understand it. My guess is that interesting. No, I'm not even going to guess. I don't know. I'll tell you later once I reread what I wrote.
Okay.
So yeah, good point, Ben.
Well, right. So, I mean, the reason I was bringing this up is that Alex and I are looking at this process that's taking up 15 gig, and we're going, okay, where'd the memory go? And this has happened before in other contexts where we were looking at the problem with OSDs inflating, and we tried your suggestion of looking at memory pools to see where the where the inflation was coming from, and we basically found that it was all in this thing called anonymous buffer, which apparently is like a catch-all, so it's kind of hard to tell. So I guess the reason this all matters is people are, of course, want something for nothing. They want to wedge Ceph in with all these other things running on the same box, and they're not content to give it its own machine, and so they're trying to run hyperconverged. And to do that, they need to be able to know precisely how much memory it's going to use and where the memory's going and all that stuff. So that's why I'm asking.
Sure. I think the problem that we have is that the mempools don't cover everything, right? In RocksDB, it's actually going to get better because we took their cache and we actually imported into Ceph and now control it ourselves. We just observe their interface for it. So we can actually add RocksDB's cache into the mempool accounting now. Instead of doing just normal mallocs or news or whatever, we can actually use our stuff to keep track of it. Radek, I think, had mentioned that may not actually be a good idea because it's apparently slower. But at least now we have the ability to do it. So that's kind of the direction we're heading, is trying to account for anywhere that we're allocating memory and then making it clear. We're not there yet, but that was kind of the whole intent behind the mempools interface, was to get us heading in that direction.
That's good.
So yeah, my guess is what you're seeing then is that it's the RocksDB cache, is that in your tests, it's giving most of it to that. The reason it would do that is either there's a lot of pressure for RocksDB with whatever test you're running, like if it's RBD, or not, sorry, RBD, if it's RGW, and there's just like tons of OMAP data coming in, that might be why you could see high RocksDB usage or getting lots of memory. Or it could just be that there's not enough BlueStore onode and data cache needed for it to request anything. It's possible that with the default options, you're not actually really using the data cache at all, or the buffer cache. And it's just basically putting all of the onodes from BlueStore in your cache. That doesn't fill it up very much, and so then RocksDB is getting the rest by default.
It seems very appropriate because with RBD you have very big objects, and on a all-flash config, I would prefer to cache the metadata first, because that's going to get you the most benefit. It would seem to me.
Yep, exactly. If we cache all of the RocksDB SST files, if there's, onodes should get priority for RBD, right? You want those things absolutely in cache. Well, there's a trade-off. If you have space for all of them, then you want it. If you don't have space for all of them, then there's maybe an argument that the version of the onode that's in RocksDB is like variant encoded, so it's smaller. So you may actually want to eat the encode and decode overhead to theoretically fit more onodes in cache. So the way that this thing eventually is going to work once this PR lands is that it's like a hierarchical cache, right? If you're hitting BlueStore O nodes, fantastic. It tries to keep those in cache, but it's kind of based on the system of priorities. And if you can't keep them in cache, you might end up like wanting to kind of like switch over. And so that was kind of the behavior that I was targeting with this, is to make it so that it tries to at different priority levels, it keeps different amounts of the BlueStore O-node cache and the RocksDB block cache in cache, and then it kind of like balances them out and adjusts. It's really kind of interesting, but yeah, so that's kind of what this thing does here.
Sounds reasonable. So, no more questions.
So let's talk about, Alex, since you're here, let's talk about your results a little bit before we move on to this other stuff.
Okay, sure.
You saw like it looked to me like in your results, the worst case was reads. Like that was where BlueStore looked worse versus FileStore.
Sequential. Is that right, Alex?
Yes, it was sequential reads that were the worst. But Ben, you had a comment on that though?
Well, right. So my comment is that, are sequential 4 kilobyte reads sort of a normal use case? And my suspicion is they aren't, because typically when you're doing sequential reads, if it's an application, if it's doing buffered reads, then there's this thing called read ahead that tends to turn the small reads into bigger reads before it reaches storage. So while the large IO size sequential reads are important, I'm not sure that the 4 KB ones are as important. So does that make sense?
Absolutely, Ben. I just posted, I think my comment there is public, so hopefully folks can see it. I'm almost positive that these results are due to a lack of read ahead on the BlueStore side. When you use FIO with the librBD backend, you don't get any kind of guest OS read ahead, right? It's just targeting librBD directly. There's no guest OS involved on the client, so there's no read ahead there in either case. librBD has the ability to do read ahead, but by default, after 50 megabytes of reads, it turns off, with the assumption that that the guest OS will take over. That was only really written, I think, is to like make it so that if you're reading like OS volumes before the OS is booted, it will like go through it really fast. It'll do a bunch of sequential reads super fast, and then it will like turn itself off to let the guest OS deal with it. So there's that read ahead, but that's not active. If you're, unless you're tweaking it, that will turn itself off, and then that's not doing anything. Now, on the back end, FileStore probably is getting read ahead from the underlying file system that it's using, right? Because FileStore is running on top of XFS or Btrfs or whatever, right? And there you probably are getting some kind of read ahead. But with BlueStore, nope, no read ahead at all. So my guess is that what you're seeing is that FileStore is getting read ahead underneath the hood. If you look at the actual reads, like with BlockTrace or whatever, you'd probably see a bunch of nice big sequential reads for FileStore, and you'd probably see tiny little sequential reads for BlueStore.
That makes perfect sense. We can try that by just turning down read ahead on the FileStore block devices, I think.
Yep.
And just see if that's true. The only question I have about what you were saying is, so essentially, I think you're right about the fact that back in the days of like OpenStack, where we had a bunch of KVM guests that were doing the reads, the Linux operating system inside the guest was doing read ahead. But as we move to more of a container-based world, is that still the case?
So from what I was talking with Sage, we can't even use librd in that environment. You have to use kernel RBD
Exactly.
unless we have
So,
like NBD or whatever, right? Or iSCSI and go through that whole stack. So
well, let's assume we're using kernel RBD for now, because I think that's the
yep.
current plan. So, uh, you know, is there any read ahead present in kernel RBD? I'm not that familiar with it. I've got to get more familiar with it.
Well, then it would be up to the OS that's doing like mounting the image, right? You use the kernel to mount the image, and now you've got this block device. Now, what are you doing with it? I guess.
So we basically could go into like sysfs and tune it that way, maybe.
I guess, yeah, I guess so. I don't actually know how Kubernetes works. I don't know what like the once you've got like an RBD device mounted, what happens? I don't have any idea. What does it do with the block device?
Well, I mean, typically what it does is it mounts a file system that's on that block device, right?
So
So there'd be like XFS or something running on it, and
yeah,
at that point it starts to look a lot like running XFS on or ext4 on any other block device, I would think.
yeah.
Assuming that,
Presumably you get read ahead there, right? If it's just like throwing XFS on an RBD volume and it's kind of all standard. I would assume you'd get read ahead.
all right, so that's something to test. Okay, that's good.
Yeah.
But assuming that works, then maybe it comes back to the idea that we're not actually going to be issuing 4 kilobyte sequential reads to BlueStore OSDs that often. That's my.
Yeah, I wouldn't think so either. I mean, we've talked about this case because at one point I was nagging Sage that we should do read ahead in BlueStore, and he's like, "This is kind of crazy. No one's gonna do this." And if they are, hopefully we have guest read ahead. There's ways around it. But if we don't, if there's really a valid use case, then maybe we should be talking about it again.
That's something that I think I'd like to look into more. So thanks.
Yeah. I'm definitely guessing that's why you were seeing those results, though, Alex. That read ahead is probably the most likely explanation for it. I did want to talk about your write results a little bit. You saw lower performance for small random writes, if I remember right. It's not much. It was like 10% lower performance.
That's correct.
Can you share your screen? Can you share your screen, Alex? Or
yeah. I think that's right. You see the chart?
Let's see if it comes up here.
I
see your browser.
Oh. Got that one?
I see your BlueJeans window.
All right, maybe it's number 1.
There you go.
That looks better.
Can you blow it up?
Yep.
Cool.
It's a little bigger.
How's that?
There.
Yeah, that looks good.
Okay.
All right. So it looks to me like, okay, yeah, rand read write, and then rand write. So the rand write case, let's talk a little bit about that. First, I just wanted to verify when you were testing this, this was basically like the stock default RocksDB settings and didn't have like perf, any of that stuff like enabled. That was all standard.
Correct.
Okay, cool. Just
nothing changed between runs except for the object store parameter from file store to BlueStore, and that was it.
Okay, fantastic. So then the next question is, Um, this is something that I need to talk to Alfredo about a little bit, but or someone who's done the system D work. But I heard someone mention that they thought we didn't need TC malloc thread cache set to 128 anymore because now we use async messenger, and I don't think that's exactly true. I've seen some cases where there's contention still in TC malloc when you do that. So I wanted to just verify that they didn't change this in like Ceph Ansible or systemd or whatever at some point and go back to the default thread cache settings for the OSDs. So that might be something to double check to make sure. That potentially could hurt BlueStore.
Okay.
And
Thread cache?
yeah, TC malloc thread cache. It's usually specified when you start the OSD. That's how we kind of did it a couple of years ago. So it's basically just like an environment variable, like it's set before you run it.
Okay.
The other thing I noticed is that your CPUs are 2 gigahertz, like base clock speed. Did you happen to check when you were running these? Did it look like those were being heavily used, and any idea if they were entering turbo mode or not?
I'm not sure about turbo mode, but I do have the results. That's an earlier run. I can't switch over right now to it, but as you can see, this is a run where we modify the memory usage, but the CPU usage per OSD is less than 10% all across the board of all of our the FIO IO sizes that we're using in the operations that we have. Like this is pretty much the data that we've been seeing consistently for BlueStore.
How many OSDs per node?
8 per node.
8 per node, and each one of them was at like 8 to 10%?
Mm-hmm. So I can
That range?
switch over to, let me jump over to per node. So just for a single node, we can see it comes up at the most of it, 60%. But other than that, it's all below.
And does this include, are these just physical cores, or do they include hyperthreading?
I'll have to check on that.
Okay. So I talk about this all the time because it's almost a little bit of a joke now, but there's a wall clock profiler, either the one that I wrote or the one that Adam wrote, that is super, super useful when you're doing tests like this to look at what is going on in the OSD. I'll link to it. Perf is also really useful too, but I just personally I find more value out of this, at least for these kinds of things, not looking at specific kind of processor micro optimizations. So if I don't know how hard it would be to just start a random write test again, and then we could try running that, but that would be really useful to see what is happening on any given OSD, kind of that's currently busy.
Definitely possible right now to run a test. We have availability right now to run a random write test. Is it any specific size or all across the board from what we're testing? We're doing like 6 different sizes, from 4K to 4 meg.
Let's just focus on the 4K one, because that's it looked to me like in your results the other sizes BlueStore is actually doing better, right?
So the one difference with the 256 and above is that it's network constrained on the host, and so it's not really reliable from these results.
Oh, I see.
Right.
So how about the 64K results? Were you network limited there?
We're borderline hitting the threshold for that.
I see.
Yeah.
Okay. Well, then, yeah, let's not worry about them at all. If those aren't valid or interesting, then let's just throw those away. Focus on these
Yep.
4K results. Um,
So what I was going to do while I have my reservation still is target again through 4K through 64 and hit the 8K, 16, and 32 just to see if there's a consistent behavior between those smaller object IO sizes.
could. I would say that I think, at least for me, the more interesting thing now is to understand the behavior of these small IOs, because I imagine that if we figure out what's going on here, you'll probably end up changing something that will affect those other numbers as well.
Understood. Definitely.
One other thing I was going to mention, the default RocksDB settings, we've been talking, this actually kind of gets into this next topic of RocksDB tuning. What we think we know right now is that our current settings are really, really optimized toward reducing write amplification in RocksDB. These big buffers are set up to really minimize unnecessary writes into L0. The hypothesis is that with our pglog updates, they're real short-lived updates. They don't stick around very long. So if we have really big write-ahead log buffers, memtables in RocksDB, we can have a tombstone come in the same buffer that the original write happened in, and then RocksDB can essentially cancel them out before they get compacted into L0. That's all the behavior we've seen seems to point at that's what's happening. And that's kind of the tuning that we ended up kind of converging on, was to reduce write amplification, and at least on our test hardware, that was faster too. But we have seen cases now where smaller buffers are faster for some people. And the likelihood, what we believe from the wall clock profiles that we've seen, is that when you have really big memtables in RocksDB, every time you do an add, or an insert, you're basically like iterating over it, doing comparisons to look for where you need to do the insertion to keep everything sorted. And that's actually a lot of CPU overhead, or at least a lot of wall clock time spent doing that. I've got a trace from our Inserta cluster where it's still faster actually to reduce write amp, but our default settings are causing the KV sync thread to spend like 30 to 40% of its time just doing these memtable adds, and most of that is like iterating over the skip list, doing comparisons. So it's really bad. It's kind of like we're stuck between these two extremes, and nothing's good. The point I'm making with all of this is that with that 2 gigahertz clock speed and the single-threaded nature of the KV sync thread, it may be that your flash devices, whatever you guys have in these nodes, might be fast enough. Oh, I'm hearing an echo all of a sudden.
Sorry, it's
Oh.
my headphones died.
Oh, no worries. So the gist of it is that you guys might actually see better performance with BlueStore if you tuned for really small memtables and ate the right amplification. It might wear your drives out faster. It might wear your flash drives out faster, but that actually might be better if you're constrained by the performance of that single KV sync thread. Does that kind of make sense?
Yeah, it does. Finally, I finally getting it. So, uh, I think we could maybe fit in an experiment where we try that once on a particular data point. And
What kind of NVMe drives do you guys have?
I don't know them specifically, but I can definitely send them over to you. The specs.
Sure. If they're high-end drives, it's quite possible that they might be able to just absorb the right amplification. I mean, it'll wear them out faster, but that could actually improve the BlueStore results to some extent. And then it's a question, then it's a decision, right? How do you decide whether or not to kind of do you eat the right amp or do you eat the CPU overhead? And it's not an easy decision to make, but it might make your results look better.
Understood. I get that. Do you mind sending some information about how to tune that?
Yeah, absolutely. I actually have a document that I linked in the Etherpad that shows what we were testing a while back. That document is here. So there is this RocksDB option in BlueStore that you can add, edit in your Ceph.conf file that has this crazy line. In fact, I think you were looking at changing some of these anyway. If I remember right in that document that you had.
Yes, that's correct. That was from your Mellanox testing. You were suggesting tuning some of those for RBD, and we were going to use the suggested ones that you had.
I don't think that was me.
You mean Micron, Alex?
Yes, I'm sorry, Micron.
Oh, yeah. And just so you know, those didn't come from us. Those they picked those up from somewhere else.
Okay.
So yeah, that wasn't us. I think they actually may have come from Intel. And Intel was doing some kind of crazy stuff, and they may have had. My guess, just based on the way that those settings are set up, is that they probably had very, very high-end CPUs in their nodes, and they were kind of optimizing for that case, possibly. Although maybe not. Well, anyway about it. You can certainly try them. I'm a little nervous that they might be not generally applicable, but who knows? I could be wrong. I've certainly been wrong in the past. So you're certainly welcome to give it a try, and if they're faster, then that's an interesting result too.
Okay. Now I think the ones that are stated in the document are from that experiment, but the ones that are in my configuration table are from this chart. Me and Ben sat down and we're discussing these settings and what are the right values from it. I remember it vaguely, but we pulled it from, I think, this chart for that configuration.
So the gist of what you're seeing in this chart, I think, is what we were just talking about, is that when you have like a single or just have like a single small buffer that's being committed at once, like in this case it's a 32 meg buffer. There's a bunch of them, there's a ton of them, but it's once one of them gets filled up, then it starts compacting it. I think what we're seeing here, the higher input and output record numbers here in red in this chart are basically the result of PG log entries going in, and the tombstone for them not ending up in the same compaction cycle, and that ends up creating a whole bunch of extra right amp. I think that's basically what's going on. We don't have direct proof of it, but it's the only thing that really makes sense to me. So my guess is that our converging here on big buffers is essentially us implicitly combating that, but it introduces other problems where now memtable adds are taking lots of CPU. So we're in the long run, we basically need to figure out how to be able to have small buffers without this other problem of high right amplification. So that's our challenge.
But just to put this in perspective, a lot of sites are still using HDD and not SSD for everything, So don't want to get people like thinking that we're saying Blue Store is bad for everything or something like that. It's there's a we've already measured it for HDD and seen big gains with it and so forth. So
And even for NVMe, your results look worse than the results we've got on our test nodes. So it might be that we've just kind of tuned this. So we've over-tuned for the hardware we've got, and maybe we can get these numbers up a little bit if we were to tune it a little differently.
right. I mean, the problem is what to use for to get something that works pretty well for most people, rather than getting something that works extremely well for a particular configuration.
Yeah, exactly. So what I'm hopeful is that once we kind of dig into your results with like the wall clock profiler and also look at some of the different RocksDB compaction numbers out of your tests, we might start being able to get a better idea of whether or not our current tunings are kind of right universally, and also what kind of right amp we're willing to accept for different performance numbers, because that's kind of the other piece. Is it's great if it's fast, but is it great if it eats people's flash drives in a year?
That makes sense, Mark. We'll take a look at it.
Understood. Thank you for that.
Cool. Well, thank you guys. Thanks for doing this. This is useful stuff. Okay, we only have 5 minutes left. But Jesse, you had a thing you wanted to add here. So, VLAs, how is that going?
Yeah, super quick note. I've just about got a PR together for RGW. So I've gone through all the VLA sites. It's still, I haven't tested it yet. I just finished it last night. But people are welcome to take a peek. There's a link in the minutes. So I will hopefully have that as PR pretty soon. And kind of as I thought, no serious surprises so far. Some sites are trickier than others, but the good news is I am seeing a lot of places where we are doing extra copies of data, and we're going to get rid of quite a few of those. So whether
Nice.
I can't really assess what the total performance impact will be from that, but I do know that there's quite a bit of it. So hopefully it'll be a win.
It's kind of humorous that by getting rid of VLAs, we're getting rid of memory copies.
Well, it is, because the most common thing that we're doing with them turns out to be taking a C++ stud string, turning it and copying it into a VLA, doing some manipulation on it, and then returning a string again.
Yep.
You know.
Well, good job. I'm really glad to hear it, because we're killing multiple birds with one stone here.
Exactly. So
Excellent.
I'll update as things progress.
Cool. All right, guys. Anything else before we wrap it up? All right. Just a reminder, next week we won't be having this meeting. It's Thanksgiving in the U.S., so have a good 2 weeks, guys, and I'll see you at the end of November.
Yeah, take it easy.
Thanks, everyone.
Thanks.
Bye.
Thanks, guys. See you. Bye.